Hi everyone, welcome to Module 1, and in this module we will learn all about infinite series. So under the infinite series, we have what we call sequences. So in this lesson, you should be able to write the terms of the sequence. Okay, but what is sequence? So sequence is defined as a function whose domain is the set of positive integers. Although a sequence is a function, so it is common to represent sequences by subscript notation rather than by the standard function notation. Like for instance, given this set of positive integers from 1 to n up to infinity, so you have this set of a sub 1 up to a sub n, which are up to infinity, which are called the terms of the sequence. So as you can see, 1 here is mapped onto a sub 2, 2 is mapped onto a sub 2, and so on and so forth. So the numbers a sub 1, a sub 2, and so on up to a sub n, up to infinity, these are the terms of the sequence. And the number a sub n is called the n term of the sequence, and the entire sequence is denoted by the set containing the elements denoted by a sub n. So after hearing the definition of sequence, let me teach you how to write the terms of a sequence. So for letter A, so given for example the sequence of this form set of the terms containing a sub n, where a sub n is defined as 3 plus negative 1 to the n power. So to find the first term of the sequence, we assign n as 1. So you get a sub 1, which is the first term of the sequence. And by substitution, if n is 1, you have 3 plus negative 1 raised to 1. But negative 1 raised to 1 is negative 1 added to 3. So you get positive 2 as the first term of the sequence. To get the second term of the sequence, we assign n equals 2. So a sub 2 therefore is 3 plus negative 1 to the second power. But negative 1 to the second is positive 1 plus 3, so you get 4. That's the second term of the sequence. So to get the third term of the sequence, we let the value of n as 3. So you have 3 plus negative 1 to the third power. But we know that negative 1 raised to an odd exponent is always negative 1 plus 3. So we get 2 as the third term of the sequence. So for the fourth term, we let the value of n as 4. So you have 3 plus negative 1 to the fourth power. But negative 1 to the fourth is positive 1 plus 3. So we have 4. So you can get the succeeding terms of the sequence by continuing substituting value of n to a sub n, where a sub n is 3 plus negative 1 to the n power. So the first term of the sequence is 2, the second is 4, the third term is 2, the fourth term is 4, and so on and so forth. Okay, next example, suppose you're given the sequence defined by b sub n equals n over 1 minus 2 times n. So again, if we assign n as 1, so you have b sub 1 is 1 over 1 minus 2 times 1. But 2 times 1 is 2, and 1 minus 2 is negative 1, and 1 over negative 1 is negative 1, which is the first term of the sequence. If the value of n is 2, then you have 2 over 1 minus 2 times 2, but 2 times 2 is 4, so 1 minus 4 is negative 3, and so therefore you have 2 over negative 3 as the second term of the sequence. For the value of n is 3, you get 3 over 1 minus 2 times 3, but 2 times 3 is 6, and 1 minus 6 is negative 5. So therefore, we have negative 3 over 5 as the third term of the sequence. For the fourth term, if n is 4, you have 4 over 1 minus 2 times 4, but 2 times 4 is 8, and 1 minus 8 is negative 7. So we have negative 4 over 7 as the fourth term. So you do the same for the rest of the terms to get the remaining terms of the sequence. So negative 1 is the first term, negative 2 third as the second term, negative 3 over 5 as the third, and negative 4 over 7 as the fourth term, and so on and so forth. Okay, another example, suppose the sequence is defined as the set of terms of defined as C sub n, where C sub n is n squared over 2 to the n minus 1. Again, if the value of n is 1, then you have 1 squared over 2 to the 1 minus 1. But 2 minus 1 is 1, and 1 squared is 1, so 1 squared over 1 is 1. That's the first term of the sequence. For C sub 2, if n is 2, you have 2 squared over 2 to the second power minus 1, but 2 squared is 4, minus 1 is 3, so the numerator is 4, so 4 over 3 is the second term of the sequence. If n is 3, then you have 3 squared over 2 cubed minus 1. Again, 2 cubed is 8 minus 1, so that's 7. And in the numerator, 3 squared is 9. So 9 over 7 is the third term of the sequence. For the fourth term, where in this case, the value of n is 4. So you have 4 squared over 2 to the fourth minus 1. But 4 squared is 16, and 2 to the fourth is also 16. But 16 minus 1 is 15. So we have 16 over 15 as the fourth term of the sequence. Tapos you do the same for the, if you want to get the succeeding terms of the sequence. Okay, next example, we have defined the sequence containing the terms of this form, d sub n, where the first term, d sub 1, is 25, and the succeeding term can be obtained by using this relationship that d sub n plus 1 equals d sub n minus 5. So if you want to get d sub 2, so you let the value of n here as 1. So you have d sub 1 plus 1, so you get d sub 2. So d sub n here is d sub 1, which is 25. So we have 25 minus 5, so that's 20 as the second term of the sequence. To get the third term of the sequence, you let the value of n as 2. So you have d sub 2 plus 1, so you get d sub 3, which is the third term. And d sub n becomes d sub 2, but we know that d sub 2 is 20. So 20 minus 5, you get 15 as the third term of the sequence. For the fourth term, you let your n be as 3. So you have d sub 3 plus 1 is d sub 4. And this is equal to d sub 3 minus 5, where d sub 3 is 15. And 15 minus 5 is 10. So these are the terms of the sequence defined in letter D. 25 is the first term, 20 is the second term, 15 as the third, and 10 as the fourth term. So you can also get the other terms of the sequence by using this relation. Okay, so in summary, we have learned that a sequence is a function whose domain is the set of positive integers and represented using subscript notation rather than by the standard function notation. So in this figure, we have here a sequence from a sub 1 up to a sub n. So each positive integer from 1 to infinity is mapped onto each of the term of the sequence. So these numbers a sub 1, a sub 2, and so on up to a sub n, and so on and so forth, these are called the terms of the sequence. And the number a sub n is the n term of the sequence, and the entire sequence is denoted by the set containing a sub n.